Hello, scholars. Professor Henkle here. Happy to share a special mention to ice. Ice is part of the hydrosphere, but it is so important we could consider it its own individual subsystem of the Earth system, the cryosphere, because ice is incredibly important when it comes to global climate. There's ice at both the poles. The entire Earth has frozen completely over 4 times in this phenomenon known as snowball Earth. What? It's true. Google snowball Earth or take historical geology with me sometime. And it covers about currently 6% of Earth's surface, responsible for beautiful landscapes, spectacular features, and supporting diverse habitat and biodiversity. Okay, so some of the things we're getting into, let's start. Types of ice. So glacial ice. This is ice that is going to accumulate on land from precipitation that stays frozen, and year after year it builds up and it freezes and it builds up and it freezes. As opposed to sea ice, that is ice formed from the freezing of seawater. Glacial ice occurs on land. When glacial ice builds out into the ocean and chunks break off, those are called icebergs. Sea ice is when conditions are so cold that the seawater actually itself freezes. So important distinction to note. Sea ice goes through a process of formation like so. When sea ice is about 1.8 degrees Celsius, minus 1.8 degrees Celsius, needle-like crystals called fusel start to formulate and create this slushy material called grease ice. That grease ice can form little sheets called nelas. Nelas become individual chunks known as pancake ice. The pancake ice will all smash together into an ice field. Now that ice field will turn into, or an ice flow will turn into an ice field. A really interesting byproduct of the development of sea ice is when the fresh water that is freezing traps in a little bit of salt, and then that salt, because it's more dense, descends down into the ocean, forming what are known as brinicles. Super salty water that descends right down to the ocean floor. Check out this brinicle video. It is so cool. You are going to love it. So sea ice can form fast ice or pack ice. Fast ice is going to be large, solid ice sheets that are attached to land, and pack ice is going to be smaller, free-floating ice out in the ocean. These pack ice can be affected by ocean currents. This is the kind of ice that trapped early explorers in the ice in the Weddell Sea when they were first trying to conquer who was going to be the first one to stand at the South Pole. There's some phenomenal stories of Arctic and Antarctic explorers from right around the early 1900s, 1910s and so. So if you're interested, there's a book called Endurance. It's the story of Ernest Shackleton, on his Antarctic expedition where he got stuck on the ice for 3 years. This book is so good. I read it in like 3 days. It was like life stops. All you do is read now. I wonder if that will happen to you too. Check it out. So pack ice will smash together because of ocean currents, forming pressure ridges. These can extend for several kilometers and can be very hazardous for polar explorers because that's kind of hard to get up and over. Also, these are dynamic features. They shift and they change and they move. Let's talk about glacial ice for a second. So sea ice is the freezing of seawater. Glacial ice is the accumulation of precipitation on land that when it gets close to the sea, it can grow out in continental ice sheets and then break off to form glaciers. These glaciers are carried by currents and are extremely large navigational hazards. Amazing video of ice undergoing the process of calving, which is the creation of glaciers, of icebergs, when icebergs break off of the main continental glaciers. Check this out, it's really cool. Shelf ice is when glaciers extend over the entire continent. Shelf ice can break off of continents into humongous pieces, this one being the size of Delaware. Antarctic ice production at sea is increasing due to global warming because more and more chunks are breaking off of these continental ice sheets and floating out into the ocean. They then are melting, thereby affecting the ocean chemistry. And as we learned in global climate change, Arctic amplification is a big issue because it's upsetting the balance of surface and deep ocean currents. Speaking of climate change, so when we look at trends over time, Arctic sea ice extent is decreasing. Now notice, this is a very dynamic process because ice forms during winter and it melts during summer. But overall, what we see is a decrease in the overall extent of Arctic sea ice extent. And it's about 3% per decade, with 2017 being the lowest maximum extent in a 38-year history of record. Time will tell the full brevity of what's happening due to global climate change, but ice is incredibly important for regulating global climate. And if the ice melts, well then the climate shifts, and if the climate shifts too quickly, we're going to have a big problem. Glacial ice in Arctic follows similar trends. We have an increased volume of melting. About 30% from 1979 to 2006, the summer melt has increased. And predictions. So if all the ice in Greenland melts, sea level rises 7 meters, about 21 feet. If all the ice in Antarctica melts, sea level increases about 60 meters or 180 feet. Now, if this happens, most coastal areas where population density is high will be completely flooded. This leads to climate refugees, the displacement of people from their homes due to climate change. So it's a pretty big issue, one worth understanding, exploring, and trying to be very, very cautious as we move forward into the future. So for our special mention ice, it forms on land and in the oceans as glacial ice and sea ice. It's an important component of the Earth system that forms the cryosphere and very important to climate. Also sensitive to Earth's climate. So it helps to regulate and it responds very rapidly to what the global climate is doing. And ice can be used as an indicator of what is happening globally to our climate. The ice is melting, the temperatures are increasing, the extent of these impacts we're still finding out today, and we will continue to learn about and understand as we move forward. So thank you very much. Thank you, ice. I'll see you in the next one.